Trigonometry, we are almost done, and that is a shame. All right, getting into it. We're going to look today at using trigonometry to find angles. So, when we do trig, we have expressions like this. Sine theta is opposite on hypotenuse. So there's three possible things we can ask you to find. We can ask you to find the opposite, which is a side length. We could ask you to find the hypotenuse, which is also a side length. Or we can ask you to find the angle here. Angle, of course, being an angle. If you want to look at find the opposite, in this case, or what's on top of the fraction, so on top of our fraction, on top of our ratio, go back 2 videos. If you want to look at find the denominator on a fraction, go back 1 video. Today we are looking at finding the angles, looking at finding this part of our trigonometric expression in there. Alright, so let's get a question. We're going to have a triangle like so. We're going to have two sides. We'll have the side here 8, might have the side here 6 as well, and we'll have theta here, our unknown. We don't know the angle, we're trying to find the angle. Okay. So just like all trig questions, we're linking two sides on an angle, we need to label things correctly as well. So here I've got my opposite, this will be my hypotenuse, and this will be my adjacent. Okay, labeling again correctly. What I'm interested in here, hypotenuse, not really a part of it, my opposite and my adjacent are. So just SOHCAHTOA, so, ka, toa. Hypotenuse is out. So is out, ka is out, toa is in. It is trig here. Tan being our trig of the day. So tan theta equals opposite over adjacent. So opposite's 8, adjacent is 6. Okay, so now we need some way to get this theta out here. Now, what we're doing here is an inverse function, which is like Year 11 extension 1, Year 12 extension 1, but we're going to kind of skip that over a little bit. What I'm going to do, if I write tan minus 1 here, that's the notation for an inverse. And what I do to one side, of course, I must do to the other. Tan minus 1, or shift tan, will cancel with tan. So these two here, tan minus 1 and tan, they cancel. So they're gone. That leaves my left-hand side here being just theta. Okay, so they cancel each other. This tan minus 1 is still applied to the second side here. So tan minus 1, 8 on 6. And mathematically, that's a little bit dodgy to write, but in terms of getting our question out here, it does work. So we're going to just apply that nicely. So theta here, tan minus 1, shift tan, 8 on 6, that will go into our calculator. Okay, you can't put normal tan in. Normal tan is different to tan inverse. It is different to this shift tan expression here. So to get that into your calculator, you want to go shift tan, and your calculator should come up with being tan, a little minus 1 sign there. Then just 8 on 6. Okay, so your calculator screen should look exactly like it looks on the screen here on my video. And then once you press equals on that, you should get theta being 53 degrees. 0.1301, etc. We don't really do decimal minutes, so you need to press the degrees, minutes, seconds button, this button here, that button there, and that button can be found next to the minus button and next to the height button. That button there is the one that we want. That will convert it to degrees, minutes, and seconds for us. So press that, I should get 53 degrees, 7 minutes. The notation is little dash, and then 48.37 seconds. So 48.37 seconds. Okay, that's our answer for our angle in here. So the setup of the question is the same. Getting the ratio is the same. Expect that to be the same every single trig question, just the solving here is different. So shift tanning both sides. grabbing another question, same thing again. So we'll draw up a question here. If I have theta again, I'll make this to be 9 and this can be 12. Doesn't matter what units, centimeters and centimeters. So running through two sides, side, side, angle, it's trig, so Sokotoa, car, toa, and working out our angle here. We've got this side here, which is an opposite. That there is going to be a hypotenuse. Okay. Opposite hypotenuse is sine. So sine theta, opposite on hypotenuse, 9 on 12. Okay. We want to crack open this theta here, get rid of that sine, we're shift signing both sides. Sine minus 1. Okay, so these will cancel, and I'll get theta is sine 9 on 12. Okay. So shift sine 9 on 12 in the calculator. That's going to get, sorry, 48 degrees. Don't forget to do minutes and seconds it. We'll get you 35 minutes and 25.36 seconds. Just note here, these minutes here,
we've hardly done any trigonometry in class, sir.
And this here, seconds, these are both out of 60. So 60 minutes in an hour, 60 minutes here. 35 minutes is past halfway. So if I am rounding to the nearest degree here, theta would be 49 degrees, because that's past halfway. That's past half an hour. So 49 degrees would be our answer for that. Basically, guys, make sure you're cancelling. We're cancelling up here. Get that cancelling right, life is good. Do one more example just to get you home.
Listen, I was bored and I worked through our paper again.
So if we have
and that's it. Extension 2. Extension 2. There's one
unknown angle, so theta there. Let's make this to be 4, and this can be 6. Labeling our sides, opposite, hypotenuse, adjacent. You need to pause, feel free to pause.
No.
Anyway, going forward, adjacent hypotenuse, Sokotoa.
You can actually get to the answer without any knowledge at all. Because you know it's not inverse sine, you know it's not inverse cos. So it has to
We're looking at the adjacent here and the hypotenuse, adjacent hypotenuse in cos here. Opposite is nothing, that's nothing because the opposite there. Nothing because the opposite there. So cos theta, cos of our angle, is adjacent over hypotenuse, so it's 416. So getting rid of that cos there, shift cos, cos minus 1.
So don't worry about that one. I did both of the logs.
Okay, they cancel. So theta,
having done it, see material, because
shift cos, 4 on 6, shift cos, 4 divided by 6, 4 on 6, will get us theta is 48 degrees, minutes and seconds, 11 minutes, 22.87 seconds. Okay, and that is it. Get some practice, it's not so bad, I think you'll find. Okay. But thanks for watching, feel free to pause, go back, go through the examples again if you need to. Have a great day.